Welcome back to another HVAC-Engineering-Techie training video. Today's training video is on plumbing domestic water systems. This is the second video in our basic plumbing knowledge series. So these are designed to help you get up to speed on plumbing systems if you're not too familiar with them. So today we're talking about domestic water. And remember, HVAC-Techie is a channel that talks all things building systems, including HVAC, plumbing, electrical. Today we'll go through this one on plumbing. So don't forget to become a subscriber if you're not already. If you are, I really appreciate it. If not, I'd love for you to do that. And the reason is Google uses that data from subscribers to evaluate my video. All you have to do is click that button that says subscribe down below. Give me a thumbs up if you like the videos. It costs you nothing. It's absolutely free, and no one will ever bug you because you do that. But you'll be able to see what videos I produce in the future. So I really appreciate it. It helps me. Thank you very much. Let's get started on domestic water systems. All right, we're going to just take a quick look at the different videos we have available in the plumbing series. And the plumbing series basically starts with D12, which is system plumbing design. It talks about how system plumbing systems are basically designed. S-35, sanitary waste and draining plumbing systems, which talks about all the different kinds of drain systems. And S-36, plumbing domestic water system, which is this video. And in this video, we're going to talk all the systems that use plumbing water, which is cold water and hot water systems. And S-37 is plumbing special systems, which covers fuel systems, compressed air systems, steam systems, medical gas systems, process plumbing, and control systems. So all these are specialties, but this is basically the water systems. And then CX-14, which is commissioning of plumbing systems. And of course, these whole series is designed to help a person that's either a new designer or a new technician or a new commissioner and has not really that familiar with plumbing. So this will bring them up to speed so they can be an effective commissioner of plumbing systems. So first, we're going to talk about domestic water systems. Domestic water systems are the potable water system, and potable basically means it's fit for human consumption. If it's non-potable water, it means it's not. It has something in it. So this would be, like this a hot water system here, which has cold water. So we run cold water and hot water down throughout the building: domestic cold water, domestic hot water, non-potable water, irrigation water, recycled rainwater, and gray water systems. And we have sterile or semi-sterile high purity water, which is reverse osmosis or water, or deionized DI water. And reverse osmosis will remove all the particulates and pathogens away from water to make it potable again. And deionized water makes it so the ions have been changed out, so it's pretty aggressive water, but it's pure. And that's used mainly for industry. If you're manufacturing something you need really pure water, it'll be RO-DI water. So they put it through an RO first, and then through a deionizer, it comes out pure. So building domestic cold water systems. Domestic cold water systems consist of building cold water, fixtures that use cold water, soft water systems, RO-DI water systems, water pressure systems, cold water specialties, which would be backflow preventers, pressure reducing valves, water meters. And on the drawings, you'll see a drawing like this, which has water piping. This happens to be domestic cold water, hot water, and hot water return. So what happens is that we run water from the main entrance through the meter all the way out to every system that needs water in the building. This has all the sizes listed. It also shows the hot water and the hot water return. Cold water plumbing fixtures. So we have drinking fountains, and they can be regular electric drinking fountains. They can just be ceramic drinking fountains. We don't see many of those anymore, but it's possible. Or these could be remote electric drinking fountains where they have the fountain fixtures, and back somewhere in a closet will be a chiller that actually makes that water cold, and these are not together. But these are all built into one. These are not. Hose bibs basically be a standard hose bib to get used for garden hose, or it can be a frost-proof one like this, which is won't freeze because it's the actually seat for this is back here, and this is supposed to be in the wall. So this is an insulated wall. The seat for this is way back here. So when you turn it off, all the water drains out of this part. So this would be the part that would be susceptible to freeze, but the actual seat's way back here. A water closet is basically two different types. So we have wall hung or floor-mounted water closets. You have bidets. You can have urinals, sinks, lavatories, mop sinks, which are used for janitorial cleanup in the building. We have showers. We have bathtubs. We have kitchen sinks, and we have kitchen cooking kettles, which basically use water as they make soups and things like that. Plumbing faucets. Okay, here's where it gets interesting. This is what drives a plumbing designer absolutely crazy. This would drive, and when I was a plumbing designer, it's been a long, long time ago, they didn't have quite as many fixtures they have today. Oh, they have tons of different looking fixtures in different finishes. This will drive you crazy trying to keep it straight and make sure you get the right thing, the right job, things on a job. So lavatory faucets come in single handles like this one, double handle like this one, or with touchless faucets that have no handles. So that's differences are available nowadays. They can come in center set, which this is a center set, which means it's close together and it's all combined together. It has 3 holes actually, but they're real close together. Widespread, which has separate holes, and the fixture is 3 separate pieces. We have single hole, which is just 1 hole, then the fixture will only have 1 hole in it for that. A vessel sink, and the difference between these two is this is designed for much larger water flow, and this is normally used for something like a bathtub or a tank fill or something like that, like a cooking kettle or something. We have wall mount, which instead of coming up to the bottom, come up to the top. Now again, these are all kinds of different styles of size. Here's where it gets tricky. Available finishes. Maybe polished chrome, which is a traditional material. Nickel, polished nickel, which looks similarly, but it looks a little more luxurious. Looks kind of like sterling silver. And then we have polished brushed nickel, which is nickel, but instead of a polished, it's brushed. It's got a matte kind of finish. Then we have polished bronze. We have satin bronze, which is a little different from brush, but it's kind of a matter finish. And then we have brushed bronze, again, which has lines in it. It looks like this one, except it's gold. Oil brushed bronze, which is a fairly new one. I've never seen one of these. Well, I have seen them, but I haven't ever installed or engineered one of these. And it's actually bronze, but it's oil rubbed in a patina. And it's a real dark patina. It's almost reddish brown. That's a different fitting. And then we have gold. And this is actually gold plated on and covered. But these are, of course, pricey, but you can buy them. And then there's matte black, which is a matte black finish. Now, in the plumbing industry, the interior decorators may really love these black fittings, but the plumber will not. And the person that, the homeowner, if it's a home, won't much like them afterwards either, because what happens is our water all contains calcium or magnesium. And if these plate out at all, they're white. And you will see these on a black fixture. Boy, they stand out like a sore thumb. So black fixtures, in my opinion, are really problematic. Besides, I don't like the way they look. So we have wash sink faucets, where these are faucets that want wash sinks, and you can see that they're just different kinds. They're not fancy. They're designed for use, work use. Or you can have a scrub type sink that has a spray nozzle on it. Medical sinks. Medical sinks usually have levers so that a person can operate it without using their fingertips or hands in case they're contaminated with blood or something on them. So they do that. They have levers normally. Mop sink faucets normally have vacuum breakers on it because they have a hose fitting. You put this in, they put a hose so you can fill mop buckets or whatever. And those are special fittings for mop sinks. Special plumbing devices, emergency wash stations for eyes. So if you're in a lab or something and you have chemicals, code will require a way to make sure you can wash your eyes out if you have the chance of that. They have full body washers, which have both eye washes and a body wash. So they'll put a deluge stream over you if you need to get rid of some acid on you. Trap primers, again, this is a trap primer. So we have an area drain, or floor drain, and it has a P-trap on it. The P-trap is designed to be full of water to keep sewer gas from entering the space. To do that, we need to keep water in that. That's what a trap primer does. A trap primer puts a little bit of water down there to keep that seal there. And you can have electric ones like this one, which can do 3 or 4 different traps. and it just has a timer here. It turns it on for a few seconds to get enough water in to seal the trap. Or you can have a drip primer, which is a mechanical device, and you just simply set the drip rate. You put it in for 4, 3, 4, 5 drips a second or drip a minute. And that continuous drip on that trap will keep water in it. You don't want too much. You don't want to waste a lot of water, but you want enough to keep it sealed so the water doesn't evaporate out of the trap. And then we have water hammer arresters. A water hammer is a bad thing to have in a plumbing system. It's caused by air in the water. And remember, in mechanical, we have a lot of ways of getting the air out of the system, but in a domestic you cannot, because it's open to the atmosphere. So because we're using the water out of the system. So what happens is we put these air chambers, and basically they're an air chamber on different various parts where we have quick acting fixtures. If you have a quick acting fixture, it can cause water hammers. So we'll put this in so we can take the hammer effect out of the piping system. Lavatory sinks, we have trim on them that we have to be worried about, and they come in what we call ankle stops for the water. And these can be multi-turn like this one, and what happens is the pipe comes out of the wall, and this goes to the fixture. It's normally a compression joint on the fixture, and this is a multi-turn, which is traditional, or this is a quarter turn, which is basically a ball valve. These are much, much better. Last a lot longer also. Inlet sizes are half, 5/8, and 3/4. So that's the inlet side. And the connection is IPS, compression, PEX, and push. So we'll go through all these different pipes, but push is just a type of fitting that's a mechanical fitting, and you push it on the pipe, and it does not come off unless you know how to get it off. I mean, there is a way to push the inner ring, and it will come off. But some of these are called shark bite, and they're very, very good fitting. They're a little pricey, but they are good. That's push. Outlet sizes are 1/4, 3/8, and half. So that's going to the fixture. Connection compression or IPS normally is compression, but it can be IPS. IPS is iron pipes size, which is threads. Drain assembly, so you have drain assemblies underneath it. They can be a lever pop-up, which is basically pops up the sink. You have a lever on the system. You pull the lever and it opens this, push it, and it closes it. Or you can have pop-ups, which basically don't have any lever. You just push it down and a spring operated up and down. And you also have a small one like this. This is a full sink tailpiece. This is one if it's going in a bathtub or something that doesn't have a long tailpiece. Or you can have just a grate where it's just a drain grate. There's no pop-up, so you don't close it off. Food shrink strainers. If you're in a kitchen sink system, you have these food strainers to be able to strain particles out of that. Our P-traps come in different sizes and, of course, finishes again. So if you have a commercial bathroom where you have is exposed underneath the sink deck, it could be chrome. They could be bronze if you need them. They could be black if you got the black, or they could be white. This could be plastic ones, depending on what you want underneath there. And then again, we have insulation covers for all of this stuff in case it's in cold country where the water will be warmer and it will condense on the outside of the pipes. The building domestic water system components. So we have whole building backflow preventers, which are designed to keep the building water from re-entering the municipal supply. And this is just to keep away from contamination. And these, sometimes this happens to be a big one, but they come very small. They come all the way from 1 inch all the way up to big pipes. So a 12 inch is a pretty big supply line. And normally, remember that the main water coming into a building may have many uses. It may have fire water, domestic water, fire water, processed water. It can be a lot of different waters coming in from one line. So these can get fairly large. You may require building pressure booster pumps if you have a higher building, mid-rise, high-rise. And the way we do that, these booster pumps nowadays are really good. It used to be in the old days, we had staged pumps. Boy, were they hard to set up because they just either didn't have enough pressure or too much pressure. But nowadays it's all VFD controlled, so you can just lock the pressure right in and be perfect. And normally what we need to boost pressure to the top story of the building to have 25 PSI for flush valves. And that's your pressure requirement. There's nothing else that needs pressure above that but that. Or if you have tank type fittings, it's 8 psi for tanks. So a tank will do a much less psi, but if you have flush valves, you need 25 psi. Actually, they'll work down to 15 psi, but there are some of them require 25 psi, so we just use 25 everywhere. We have water meters. We normally have a water meter on the main municipal lines. They get tough using water. But we may have sub-meters down below that, or we may have separate meters. So you may have one meter, a utility meter, going to the building for domestic water, and one going to the landscape as irrigation. And the reason for that is that municipalities charge different rates for water and for sewer. So if what you need to do is if you have water usage that don't go to the sewer, like cooling towers or irrigation, you want to make sure you can meter those separately, and the utilities can meter those separately, so they don't charge a sewer fee for that, because there's no sewer fee involved because it's not going to the sewer. So that's what it's all about. Now, another little secret is that municipalities normally use the month of February to calculate that sewer fee. They don't measure it every month for sewer fee. They measure the water every month to get the amount of water they're charging you for, but sewer fee is normally adopted from 1 month use. Why they pick February, I don't know. They may pick other months, but normally it's not an active situation. Reduced pressure valves, in case you have too much pressure. Municipalities are required to give you at least 45 psi, but I've seen as high as 125 psi, depending on the control system they have for municipal water. Again, if they have stage pumps, it might bounce around a lot. Or, which is more troubling, is when they put a pumper truck on it, and it may actually overpressure the water line. So sometimes you do require pressure reducing valves. Pressure reducing valves are normally 45 to 85 psi. And one reason this is important, you don't want to overpressure the building. You need that pressure for that top story all. You don't need over that. If you get over that, you get above 85 psi, and even the difference between 45 and 85, the flush valves need to be adjusted accordingly, or also waste a lot of water. What happens if you have an 85 psi in a flush valve, it'll hold it open for a long time, and it'll pump a lot of water down through the fixture. So on the fixtures on the first floor, you have to adjust that water so it has a lot less pressure coming out of it than you do the top floor where you don't have it anyway. So if you don't want to waste a lot of water, you need to make sure that's done correctly. Special system consideration, high-rise building water pressure control. Now you realize that water pipe comes in 125 psi, 150 psi, 300 psi, 600 psi. So there's a lot of different burst pressures of the pipe. Well, in high-rise buildings, you have two problems. One is you have to make sure you're not exceeding the burst pressure of the pipe, and two, you not have such high pressure that your fixtures won't operate correctly. So in a high-rise building, they normally go 20, 25 stories and then separate the systems into separate systems. So you have one system that has 25 psi at the top and 45 psi at the bottom, and then it feeds water into a tank, and that tank then has a pump distribution, and it pumps it up another 25 or 30 stories, and because 30 stories, 200 psi in water, so it's a lot. It's a challenge. So that you can't just have one large water pressure system. As one, the pipe would be really expensive. You'd have to have pressure reducing valves everywhere. Now, even on a high rise, if you're doing 25, 30 stories at a time, you probably have to use some pressure reducing valves in the different systems and not have overpressurization. So high-rise buildings and pressure control is a very serious consideration that a lot of people don't think about for plumbing systems. Pipe and fitting burst ratings is 125, 150, 300, 600 psi. Now, copper pipe, these are way low because it goes, a half-inch copper pipe is probably good for, 1,000 psi or so, a lot. But plastic pipes are not, so you have to be careful of what you're using in a building for water piping. Here's a little chart of the approximate working pressure, and it's approximate because everything matters about temperature. So if you have 73 degrees, which is considered the standard for cold water, might get colder in the winter and warmer in summer, but that's basically it. You'll see that schedule 2-inch PVC Schedule 40 is good for 166 psi. 1-inch PEX, which doesn't come bigger than 1 inch, is 160 psi. 2-inch copper L is 364. 2-inch copper. Now this is 2-inch copper. I'm using 2-inch because it's normally the worst case. We get water mains in bigger buildings bigger, but not a lot of them. I mean, normally we break them up. A 2-inch K is 435. 2-inch steel is 1500. 2-inch Schedule 80 is 2000 psi. But look at 200 degrees. If you've got hot water, no PVC, 1-inch PEX, only 80 psi. 2-inch copper, 297. 2-inch copper type K, 355. But steel doesn't matter. That temperature is no concern. But for plastic pipes, temperature is a problem. We have to be careful we don't exceed those parameters. So domestic water softener systems. We do have softener system in it. Now, a water softener utilizes salt or potassium chloride to remove calcium and magnesium from the water by ion exchange. This is done to lower the total hardness of the water. And normally, these systems are only on the hot water system, because that's somewhat more common, but they may be on food systems in different places, so there may be different requirements for water softeners. Now, this happens to be a smaller type water system that uses 2 fiberglass resin tanks, and this is where the resin is. And what happens is it takes the reason they have dual is because when one senses it needs to regenerate, it turns off and turns the other one on. So now this one's working. And it takes clean water and back flushes the resin to clean it up, make sure that any solids or anything gets out of there. And then it takes the salt water and it infuses the salt water across the resin, which causes the change of polarity or static charge on the ions, basically it's changing ions. And when it's fully done that to the tank, then it stops and it rinses it with clean water and then it puts it back into service. Now it can actually remove the calcium magnesium by basically changing a static charge. And that's how all water softeners work. Now, potassium chloride is a salt. It's chloride, but it's potassium. So this is actually like a fertilizer. So if you have things on it that you don't like, people don't want salt in their system, potassium chloride tastes a little like salt, but it's actually doesn't do the harm to the body or the plants. If you're trying to water plants with this water, you got salt in it, you'll kill the plants. So this doesn't work. This is a larger water system, and this can be a 3 or 4 tank system instead of just a 2 tank. And it depends on the water flow. You have to size these based on the total water flow of the system and how long you want it to go between regens. So the sizing these there's a special process to size these, and that's covered in the design process system. Water softeners, softener tanks, salt tanks, controlled systems, high purity systems. That's the reverse osmosis. The reverse osmosis has a membrane in it, and it puts water through at high pressure. It takes a lot of pressure to put it through the RO membrane, and it removes very, very small particles, which includes viruses and pathogens from the water, and also most of the solid water also. It's not pure when it comes out, but it is very clean, and that's how we use RO a lot of times to clean up water to make it potable water. Deionized water, on the other hand, is RO water that we put through a deionizing process, and it changes the ions of the water again, making it very pure. Now, one thing you got to understand is pure water means aggressive water. When you clean up water and make it really pure, it becomes very, very aggressive corrosion. It will corrode things. So we have storage tanks in the system, we have filter systems, we have pumps, and it's normally used for clean water for cleaning or consumption, and for manufacturing processes that require very clean water. So RO we use in most restaurants use RO water for their drinks. Alcohol beverage tastes much better if the water in is pure. And also for drinking water, when you go into a restaurant most of the time, the water tastes really good because it's right out of an RO system. And DI water is used for manufacturing processes when there can't be any contaminants. When they use the water to clean something, there can't be contaminants or residue left behind. So DI is what it's used for. This is a small RO system like you use under your kitchen sink to get drinking water. That's what I actually use in my houses because I've actually worked in municipal water plants, and I think I'll take all that stuff out of my water. I don't like chlorine in my water, and I don't like, I don't know, in my area, which I've lived most of my life, I had worked in these plants, and I could tell when it rains a lot that the water changes flavor because their systems are overflooded with water and their system clean. So I said, oh, that's enough of that. I'm going to bottled water, or I now make my own with RO water. And this is a commercial system. This has a whole bunch of RO membranes. It has pumps because these pressures need to be fairly high, 400 or 500 psi through this membrane. And they do waste water because it may take, for every gallon of water it purifies, it may discharge a gallon to half a gallon of water. So you can't use a lot of water to do that. And this is a DI system. So this is an RO system. This has ROs behind it right here. It takes the RO water and puts it into the DI tanks to deionize it. You see, this is all stainless steel. This would be a commercial DI system. Reclaimed water systems. Reclaim water from rain collection, cooling tower blowdown, fountain overflow, and other clean, non-potable services. So we can take this water. If you're going to collect this water, you can take and use this water for irrigation. And it becomes very, very effective as long as you live in an area that has enough to be able to do it. A cooling tower blowdown has particulate matter in it because it's got stuff from the cooling tower, but it's still not terrible water. It can be used for irrigation. You want to drink it, but you can use it. Fountain overflow, same thing. And other clean, non-potable sources. So they need storage tanks, filters, pumps to take care of this. It's used basically for irrigation. But you can, if you need water very seriously, you can take and reclaim this water and run it through RO system and chemically treat it, and it can become potable again. Not many people do that. Normally they either put it back down in the ground to purify it or use it for irrigation purposes. And these come normally in a skid system if you want, but you can have tanks back here that take the rainwater. You need to have pumps and filters to get it back into the system. But these are really handy for irrigation if you're using irrigation. And then there's gray water reclaim system. Now, gray water is not potable at all. This is water coming from plumbing fixtures such as sinks, showers, bathtubs, drinking fountains, process drain, and clothes washers. There's no black water, so you can't have any water closets or garbage disposal or animal wash down drains anywhere like that that's going to have fecal matter in the water. Cannot be run into a gray water system. Collection piping systems, so you got to pipe this water separately. Storage tanks, pumps, filters, chemical treatment systems, and normally used for site irrigation or flushing black water fixtures. So if you're really serious and you don't have a lot of water and serious, you can take and collect all the water from your sinks, showers, bathtubs, and run it through a black water or gray water system and put it back into the water closets as flushing water. That means a lot of different piping systems, but you can do that. And this would be an example of it, where you see the bathtub and the sinks and the clothes washer come to the holding tank. It goes to a system, and then it comes to use for irrigation water after that. So it is possible. We don't see many of these anymore because they are a lot of maintenance. There's a lot of trouble, a lot of maintenance. But if you're really serious and you don't have a lot of water, then this might be something you would consider. Domestic cold water pipe. So PEX tubing, which is a plastic type pipe that's used mainly in residential, 1/2 inch to 1 inch. And this is the blue and red pipe you see running around a house. And this is now accepted as be long-lasting enough for residential environment. Copper pipe is traditional, type K, L, or M, with wrought copper fittings, solder, braze, compression, groove joints, or crimp joints. I didn't get crimped in here, but it could be. Galvanized steel pipe with galvanized steel fittings, threaded or grooved. PVC, CPVC pipe with socket weld or screwed fittings, fusion weld or groove joints. Schedule 80 threaded. You can actually thread PVC. There's fiberglass, bell and spigot, etc. Can be used for domestic water. On sites, we use a lot of this plastic pipe, fiberglass and plastic pipe for that. So this is generally the type piping. So now we're seeing mainly copper and PVC and CPVC, and there are a whole bunch of other plastics I'm not put in here. So I don't know what they're called. I've seen them on job sites for piping. It's a gray pipe with a green stripe on it. I don't know what it is. I did a couple of large dormitories that use this piping. However, I noticed on the second job they didn't use it, so there must have been a problem that I'm not familiar with. These are the traditional materials you might have others. Ductile iron pipe for underground, 3 to 54 inch, big pipe, pressure glass is 150, 200, 253, and a 350 PSI, depending on what you're using the water pipe for. So PEX tubing is coiled tubing. They have special connectors for this thing. You can get valves, special hangers for this plastic tubing. You get barbed tees. This is a female adapter. This is a male threaded adapter. This is just a coupling. This is an elbow. This is a crimp coupling where you put it on that barb and you put either a screw clamp or a crimp clamp on it. It has compression couplings where you push the material in and tighten the clamp. Or it has push couplings. So these are the push ones I tell you, like a shark bite fitting. You just simply push it in there. This one you put in there and take a wrench and close it around it. This one you just push in there and it's in there. And if you got to get it out, you got to take that little yellow spacer you see there and push it in and then move it out. It's a little awkward, but you can get it out as long as you get the teeth. You have to make sure you raise the teeth so it releases the pipe, or else you can't get it off. I mean, you just cannot. I've tried pulling one off, otherwise it's just not possible. Copper pipe, which comes in tubing sizes. It has ball valves. Normally, we use pretty much, we should use ball valves everywhere. We still have gate valves and globe valves, but the ball valve is so much superior for water service. That what happens is the other valves fail due to corrosion or whatever, and the ball valves do not. So the ball valves have stainless steel balls and brass fittings. And then, of course, we have unions, copper fit unions. We have male adapters, female adapters, couplings, gaps, elbows, tees, copper hangers, different bigger hangers, single pipe clevis hangers, and strap hangers. And what you notice about these hangers in copper, that they're made from copper or copper coated. And the reason is you can't put a copper pipe on a steel hanger. It will corrode because the steel and copper do not get along. So either you have to wrap the pipe with black tape, but you have to prevent the pipe from touching a non-copper hanger. So that's why copper hangers, they actually make them in copper to prevent, or copper coated to prevent that from happening. So they come in solder joints, which is a common one. You can have crimp joints, which is taken over the world by storm, by the way, lately. Or we can have push joints, all in copper when we want that. So galvanized steel pipe has ball valves again. Now, you'll notice that this is a brass valve and this is a black iron pipe, and steel and copper and brass don't get along. However, because of the way corrosion cells work, is what happens is the brass, whenever you have a corrosion cell, it always goes from the steel to the brass. Okay? So the correction will take a piece of material, etch it from the steel pipe, and plate it onto the brass. Well, if you have a ball valve on 200 feet of pipe, ain't everyone ever going to know, because there's not enough brass to attract enough ions off the steel pipe. However, if you take a copper system and put a steel piece of pipe in a copper system, buddy, it's gone in months. It will just erode it to pieces. And that's where people get in trouble, where they'll use to a hot water heater, they'll use a piece of steel pipe nipple, and that won't work, because that's the opposite. There's a whole bunch of copper out there looking to steel pipe, to steal the ions from steel pipe. So you can use a brass valve on a steel pipe system. You cannot use a steel valve on a copper system. And of course we have T's, elbows, couplings, reducers, all kinds of fittings, caps. There's a lot more type fittings that I'm showing, but these are the basics, but you get all kinds of them. And these are nipples. And this is the one thing you would never want to use a copper system, because this will just eat its pieces very quickly. And of course we have plugs and straps. We also have hangers, steel hangers for different size steel pipe. And of course, all theirs are screw joints. You can do welded joints, but in plumbing we don't do that. We don't do that for process piping. And this is the corrosion I was just talking about, brass, copper to steel. It's okay to put a brass valve in a steel system, not the other way around. PVC piping, basically we have the ball valves again, and that you can actually have plastic ball valves, but in a regular plumbing system, don't do it. Use a brass valve. The plastic ball valves are used mainly for high acidic values, but they're not long lasting as a brass ball valve. So we have plastic PVC unions. We have male thread adapters, female thread adapters, couplings, caps, plugs, elbows, T's. Normally it's always glued joints. And then we have trapeze hangers, and trapeze hangers can be used for any of these. And you can use clevis hangers like these or like these, anywhere from PVC, because PVC is not corrosive, it doesn't care what the material is. Trapeze hangers, on the other hand, we use where we put a whole bunch of pipes on one hanger. And there's a little bit of a problem here in that, remember, the water pipes are actually heavy. The pipes themselves are not, but the water in them is. So these trapeze hangers have to be properly engineered to be able to support the amount of pipes. So that's something that they need to do. I actually have developed charts of standard pipes or standard weights for trapeze using Unistrut. But basically, these need to be engineered so that they're going to not have a problem holding that much weight of the water. But you can do that. All these type of pipes can use a trapeze hanger. They can use clevis hangers like they showed, or strap hangers, but they all can use trapeze hangers. Building domestic hot water systems. So building domestic water fixtures that use cold and hot water specialty components, hot water heaters and boilers, circulating pumps, expansion tanks, temperature mixing valves. And again, the drawings normally show the hot water heaters and the different systems that they use for the hot water, and it will show the supply lines and the return lines for the hot water. And again, a bidet can use hot and cold water. Lavatories use cold and hot water. Wash sinks use cold and hot water. Mop sinks, showers, of course, bathtubs, of course, and kitchen sinks all use hot and cold water. Water heaters and boilers. We have different kinds of boilers. We have, this is an electric tankless water heater, which means it has no storage tank. It's an instantaneous heater. So they have to be big enough so that all the water the flow rate you're going to use for a shower, the flow rate you're going to use for lavatories doesn't exceed the flow, maximum flow of the instantaneous heater, or else the water won't get hot. So they do have to be sized correctly. This is a gas tankless unit, which uses natural gas to heat. This is a tank-type electric hot water heater. This is a gas water heater, tank-type. This is an electric boiler. Electric boilers basically are used in conjunction with a storage tank or non-storage tank to heat the system up. And this is a gas-fired boiler that can be used for domestic water. Now, normally these use a storage tank with a heat exchanger inside of it, so this water is not exposed to the potable water. And this is kind of low here. You can see here is a storage tank. And here's our boiler system. You can see it's got a heat exchanger in here, so the hot water comes out. And this is designed to have a heating system over here. Takes the hot water, runs it through the hot water heater and back, and that's capable of using a boiler to make your hot water system. Hot water system components, recirculating pumps. These are different than a pressure pump. These are just designed to circulate the water in the system lines to keep them warm. So you take a little water from the last fixture and you circulate it back to this hot water heater, and it will keep the entire main warm. So you don't have to wait forever to get hot water. And this is a mixing valve. And this mixing valve, you take 140 degree water and you can mix it with cold water. You can come out with 120 degree or whatever you want. Now, the reason we use mixing water is 140 degrees can scald you. 180 degrees definitely can scald you. So basically what they want for humans, 125 is not scalding. It's hot, but it's not scalding. But the other problem we've got is Legionella. Legionella can grow in a hot water system. It loves 95 degrees water. So if you have a system and you put it down to 95 degree water, you will grow Legionella, because Legionella is in the air and in the dirt. It's a microbe that's in the dirt everywhere. And it will grow inside of a hot water system. If your hot water system has pink slime on the inside of it somewhere, That's actually a Legionella not virus, but bacteria. So what you need to do to prevent Legionella, you need to be above 125 or above 120, above 120, so 125, and you can be under 140. If you're trying to use hot water for dishwashing, it needs to be 180 degrees. So normally we have booster heaters at dishwashers to make sure we take 140 or 125 degree water and boost it up to 180 degree water. And then we have blow-offs for the boilers. These prevent the boiler from being overpressure if something happens. So they discharge the hot water to atmosphere. And then we have under sink hot water mixing valves. And what we do here under sink, we put out this manual valve under there, and you adjust it to make sure you get the temperature you want. And it will always mix the water at the sink level. These are used in commercial bathrooms or whatever that mix the hot water and cold water together so we don't get a scalding situation on a person. And the expansion tanks for any time we have a hot water heater, because cold water or hot water does expansion, these expansion tanks, so they put those in there. Solar water heater systems where we have tanks that take the water, and when the sun's available, it'll make hot water. We have a system storage tank over here that will actually take the hot water and distribute it to the home or to the building. And this normally has electric heaters in it as a backup. And you can get collectors that are tube type, which are actually more efficient than a plate type. You can get them in systems of different kind of collectors, different kind of components. Glycol drain back systems, so they drain back if you want. Pumps. This is a pump control module. Storage tanks, of course, expansion tanks again, and control modules. It used to be we built all this up in the field, but nowadays you can get one of these modules that includes the pump and all the controls required for the entire system. You still have to have a storage tank and collectors, but this does everything in one deal. So domestic hot water pipe, PEX tubing again, 180 degrees max, 1/2 to 1 inch, crimp, push, compression, shark pipe fittings, copper pipe type L, K, L, or M with wrought copper fittings, solder, braze, compression, or crimp joints, galvanized steel pipe with galvanized steel fittings, threaded groove joints, 1/4 to 24 inch, big pipe, stainless steel pipe, schedule 40 or tubing, and this pipe, the copper pipe is 1/4 to 6 inch normally. 6 inch is really expensive, by the way. Socket weld threaded compressive clamps, CPVC pipe with socket weld fittings, fusion weld or glue joints, 1/2 to 12 inch, and schedule 80 threaded, 180 degrees max again. So remember, what's not on this list is PVC, because it won't take any temperature at all. So we normally don't allow PVC for domestic cold water or hot water. So site water systems, so the main utility feed coming in from the main utility water to the building. Well water systems. Now, one thing about main feed systems, especially if you have a loop going around the building with fire water on it, you'll notice this has this little fitting here. This is a flange restraint device, so it's designed to make sure this flange cannot come apart. And it attaches to the pipe and makes it come this way, which means on pipe for water systems, we have to be aware of water hammer in the system. So normally water mains have thrust blocks poured on the elbows to make sure that if a fire pumper gets on there, these fire pump trucks can pump hundreds of PSI to try to get water to a fire, and they can cause the underground mains to split at a joint. So we have to make sure these joints are protected from that surge pressure of a fire truck. We have water well systems if we have water wells on our site. And these are normally different kinds of pumps, but they're available in all kinds of configurations. Fire pump water for fire hydrants, site irrigation systems, site water main components, big backflow preventers, of course, water meters, booster pumps in case the pressure coming in needs to be boosted, storage tanks. You may need large storage tanks on the site if you have a compromised water supply, especially if you have fire protection inside of a building, may require a storage tank. Fire hydrants, post indicator valves. These post indicator valves are used for the site, so fire officials. These post indicator Valves are used to shut off or open valves in the main, and they have post indicator valves, so fire protection people can know what position the valve is in without looking down below. Domestic water wells, they have deeper wells, or this is the aquifers, so they have shallower wells, and the wells pump into a storage tank, and then need a pressure tank to distribute the water to the dwellings or to the buildings. Water well components or well pumps could be submerged pumps like this one, which is submerged down to the bottom, and the pipe holds the pump down to the bottom, and the wires come down the side to make it run. Our turbine pumps, which are commercial wells, can be turbine pumps, and these basically are above ground on top of the wellhead, and then these extend down to the basin where it's going to suck water up. The only problem we have in my area is the water wells could be 1,000-foot deep, so this could be quite extensive if that's what you're trying to use. Pressure tanks, pressure booster pumps, again, to boost the pump pressure, storage tanks to store the water if you need it. So we don't have a lot of well systems used anymore in a commercial type building, but it's possible. Irrigation system components means backflow preventers. Again, this is one you can't have it coming back into the system. Water meters, pumping systems, controllers, water meter control, or water irrigation controllers, and these can come. The water irrigation controllers can be small, like the residential, or can be quite large. Largest system I ever did had 700 control valves on it, and had I think 2,500 emitters. It took me weeks to do this system. It was quite a system. Had three major. It was so big it couldn't have it all in one controller. It had three major pedestal controllers. It was a big system. Control valves are normally like this. That would be a 1-inch valve, and they're pressure compensated valve. This is the solenoid that opens, and the water pressure is used to actually open the valve. Distribution sprinkler heads can be impact type, which is sprinkle turf. Pop-ups can actually do turfs where they pop up when it's on. Bubblers, which are used for garden planting areas or whatever, and they bubble like that. Or we can have drip irrigation system that use different kinds of drip heads, with the color indicating how many gallons an hour the thing is capable of doing. So those are the different types of irrigation we use. I can use flood irrigation also, but we don't see that much anymore. Irrigation piping system, copper pipe type K with rod fittings, solder braze crimp. PVC, this could actually be type L also. PVC, CPVC pipe with socket fittings, glue joints or flange joints, others. Polypropylene compression fittings, fiberglass melon spigot, many others. This is the polypropylene we use in drip systems, which is a tubing, has special push connections. These are also tenacious. The only way you can get a piece of tubing out of this is to cut the tubing and twist it in on itself to make it smaller diameter to pull it out, or else you can't pull these out either. So those are good. So that's basic for water piping, just trying to get you familiar with the different components of water piping. There's actually plumbing is simple, but it's a lot to it actually. Having been through the different phases, I've been a plumbing contractor, another designer, and a commissioner. So hopefully that helps, and hopefully you learned something from this. I really appreciate you watching the videos. Have a great day. I'll catch you on the next one. Thanks.